Combustion is a fancy word for burning, and burning is a quick reaction with oxygen. So when we look at the term combustion reactions, oxygen in the form of O2 is always going to be a reactant. And at room temperature, oxygen is a gas, so its phase will always be a gas. We're going to look specifically at combustion of hydrocarbons. Hydrocarbons are a large class of chemicals that are made only of carbon and hydrogen. And they are often used as fuel because they release a lot of heat when they undergo combustion. A combustion reaction that involves hydrocarbons will always form carbon dioxide in the gaseous form, as well as water in the gaseous form. Now, I say always, but there has to be enough oxygen around. We're going to assume that we're going to have sufficient oxygen. If we don't have sufficient oxygen, we'll make carbon monoxide, which is extremely toxic. But we're going to assume we have enough oxygen. So carbon dioxide is always a gas at room temperature. H2O is typically a liquid at room temperature. However, so much heat is given off by these chemical reactions that we're going to assume water is going to be in the gaseous state. So you are going to be expected to know that a combustion reaction always means reaction with oxygen, and if we're looking at the combustion of a hydrocarbon, carbon dioxide in the gas phase and water in the gas phase will form. So as we balance combustion of hydrocarbon reactions, there's a systematic way we want to approach it. We have an element here, oxygen, so we balance that last. Balance carbon first. The carbon in the hydrocarbon will always go to carbon dioxide. So I have one carbon in this chemical equation, and I have one carbon in my one carbon dioxide. Next, balance hydrogen. So I have 4 hydrogens, and I will balance my hydrogen by placing a coefficient of 2 in front of the water. So after we balance the carbon and the hydrogen, the last thing we look at is the oxygen. So I have 2 times 1. So what am I saying? Oxygen. Yeah, 2 times 1. That's right here. 2 times 1 from my water, and then 1 times 2 from my carbon dioxide. So I have a total of 4 oxygens. So if I place a coefficient of 2 in front of my oxygen, it's balanced. Now sometimes it isn't always that easy. What I'd like you to do is balance carbon first, hydrogen next, and then oxygen last. Pause the slide, go ahead and balance that and see what you come up with. So looking at this chemical equation, I have 6 carbons, so I'm going to put a coefficient of 6 in front of my carbon dioxide. I have 14 hydrogens in my hydrocarbon, so I'll put a coefficient of 7 in front of my water. So my carbons and my hydrogens are balanced. 6 carbons on both sides and 14 hydrogens on both sides. So let's look at my oxygens. I have 12 oxygens from carbon dioxide, 6 times 2 is 12, and I have 7 oxygens from water, 7 times 1 is 7. That gives me a total of 19, which is an odd number. So to balance my oxygens, I have to have 19 halves O2. Now, as we've already talked, we don't want to have a fraction, so we'll multiply all my coefficients by 2. So I'll place a 2 in front of my hydrocarbon. When I multiply 19 halves by 2, I get a coefficient of 19. Multiply 6 by 2, I get 12, and 14 waters. So I look at my coefficients, I see that there's not a common factor between them except for 1, so that's good. Now let's look to see if it's balanced. Carbons, 2 times 6 is 12, 12 times 1 is 12. My carbons are balanced. Hydrogens, 2 times 14 is 28, and 14 times 2 is 28. So my hydrogens are balanced. Now let's look at my oxygens. I now have 24 oxygens from carbon dioxide, and I have 14 from my water. And so that gives me a total of 38, and 19 times 2 is 38. So the chemical equation is balanced.